Hello, everyone. My name is Caroline Lair, and I'm the founder of The Good AI. We are a community of 200 plus AI talent and startups on a mission to help companies being more sustainable. Michelle, you want to introduce yourself?
Yes, so hello everyone. I'm Michelle. I'm also with The Good AI. I'm working with Caroline, and I manage the community and content activities. And we look forward to starting the conversation with you guys today.
So we're glad to welcome 3 of our members today, 2 startups, 1 researchers, and 1 corporate guest to chat about how AI can help mitigate the world energy crisis. So indeed, Europe is preparing for quite a challenging winter without gas from Russia, and energy efficiency has becoming crucial. So it's interesting because it's generates multiple benefits from reducing energy demands to reducing CO2 emissions. Under normal circumstances, it's essential, but in this time, it's becoming very imperative. And this is where applying AI to energy efficiency can deliver quick result very quickly. One opportunity for Europe this winter, for instance, is to better leverage the smart meters installed around the region with connected mobile applications that allow end users to understand and manage their real-time energy usage. So today with our guest, we're gonna, in the next hour, we're gonna dig a bit more into these opportunities and ways to accelerate them.
All right, so just a quick run through of how the event will go. We will start off with a short introduction of the speakers and their companies, which will be followed by a 30-minute conversation between the speakers. At this point, you can then ask your questions during the conversation, but we will answer them at the end. We will have a Q&A with the participants in the last 10 minutes. So in order to submit your questions to the speaker, you can use the chat at the right. And then for the attendees, just feel free to mention your name and position when you give your questions.
Thank you, Michelle. So now it's my pleasure to welcome all of our speakers. Hi, Priya. Hi, Nicholas. Hi, Georg. Hi, Henton. Welcome. Welcome in this conversation and welcome. So we're going to ask each of you to present briefly. Oh, I think one of you might be, yeah, if you can go mute. It's a bit noisy. Yeah, so we're going to ask each of you to present yourself, your company or your community and your work in a few words, and then we'll move shortly to the conversation. Priya, you want to start?
Yes. Hi, everyone. I'm Priya Donti. I'm the co-founder and executive director of Climate Change AI, which is a nonprofit that mobilizes the use of data science to address climate action. And we do this by providing a combination of educational resources and events, opportunities to network and connect and team build with other people, funding resources, and also shaping the policy discourse. I'm additionally, in another hat, an incoming assistant professor at MIT, where my research focuses on the dynamic optimization of power grids using machine learning, but with safety guarantees, which is something very critical to optimizing power grids. So really happy to be here.
Perfect. And Nicholas, if you would like to go next.
Yes, thank you. Sorry for the background noise. I'm in a conference and they are removing chairs. So I'll put myself on mute in due time. So thanks for the invite. Brainbox AI is a startup company in Montreal, based in Montreal. We started our company in May 2019, and currently we're 150 people impacting 300 buildings across 20 countries. So basically what we do is, our goal is to decarbonize the commercial real estate as well as providing grid flexibility. So we use the most advanced AI to manage HVAC system in commercial buildings. As you may know, the real estate sector is responsible for about 40% of the global GHG, and HVAC system is responsible for 50% of the entire energy consumption in commercial building. So it's critical if we want to be successful with our energy transition and our race to net zero to manage the energy consumption in commercial buildings. So I'm looking forward for the discussion tonight.
Thanks, Nicholas. Anton, please, can you introduce yourself and your company?
Absolutely. Thank you, Caroline and Michelle. So I'm Anton from Southern Lights. We're based in Stockholm in Sweden, and we work in the sector of green hydrogen. So as you know, like 30 years ago, solar PV installations was a new thing, and we've since seen like an exponential growth of solar, and also wind power has become increasingly cheap. And this has, of course, been great for the energy system, but the energy transition really doesn't stop there. We will now need to take that cheap and abundant clean energy to the hardest sectors in society. We're talking big polluting industries such as steel production and fertilizer production. And these industries, they cannot really directly electrify in an easy way. So they typically need energy in a chemical form. And one such form is hydrogen gas. And this is why energy companies right now all around the globe are looking at how to produce green hydrogen as a replacement for fossil fuels. But this technology is really at the base of the learning curve. So the market is still struggling to get these hydrogen production projects out the door. That's why we at Southern Lights are creating the next generation of digital tools to help the project developers to understand the economics and assess these type of hydrogen production projects. And into this also comes many factors. I mean, these installations are not an isolated part of the energy system. They come in to replace natural gas, which is a shortage in EU now. After the events this year. So and also they are participating in the electricity grid in many cases. So we also see use of AI in this sector. And one thing that really sets this transition apart with the green hydrogen, apart from previous energy revolutions, you can say, is that we now have the power of AI. So we can speed up this development and get to scale in these new technologies faster than we could before. And that's sort of what we're working on.
Sounds very interesting. And lastly, Georg, if you can introduce yourself and what you do at Siemens Energy.
Yeah, many thanks, Michelle. So Georg Hollmann is my name. And I'm working with Siemens Energy, who is an integrated energy technology company with a global presence. I think we're about 90,000 people overall. And we're helping our customers really along the value chain to decarbonize, and mainly in three areas. So number one is the power generation with low or zero emission power generation solutions like gas turbines, also ready to burn hydrogen. Like Anton explained, steam turbines, power plant solutions, wind turbines. Then we have a second sector, which is the transport and storage of energy with transmission and distribution lines, but also storage solutions. And then thirdly, we are helping our customers in the industry sector to decarbonize, for example, by utilizing hydrogen coming from electrolyzers that we're building, and also decarbonization of industrial sectors as a whole. And my role here is I'm heading the advanced analytics and artificial intelligence team that is looking really across the value chain from a central function perspective, how AI can help, in various aspects from design, manufacturing, really along the value chain, service, operation, and also building, let's say, the best solutions from a kind of optimization perspective. So yeah, really looking forward to the discussion today.
Fantastic. So we're going to move to the conversation now. And so basically, we're thinking about three parts. The first one is how can we accelerate the energy transition with AI? Feel free to give concrete example. The second one is the challenges in the space. And the last one is the energy problem of AI itself. So this conversation is really yours. So feel free really to chat with each other and question each other. We're here to listen also to the dialogue that the four different actors like you, representing academia, industry, and startup, can have in this area.
Great. So just to launch this conversation, so the first question is, how do we accelerate the energy transition with AI? So you guys feel free to give concrete examples if you have them.
Yeah, maybe I can start. So as we all know, the energy transition is about a more intermittent grid, and as well as a more decentralized grid. So this creates real challenges for the grid operator to balance an intermittent supply with a stable demand. So we need to have flexible resources to replace the current balancing resources, which is natural gas. So one of the key elements is to try to optimize what's existing, the existing assets, the existing infrastructure. What we do at Brainbox is we optimize the commercial sector, and we use the HVAC flexibility to provide such flexibility into the grid. So we transform each building into a thermal battery. But understanding unlike the conventional battery, the storage of a building varies through time on a daily basis. So we need to have a deep understanding, a lot of data in order to understand the thermal characteristics of the building. So we use those AI to define these characteristics and also to analyze the behavior of the building under those different characteristics. And with the AI also, we optimize the operation of the HVAC system with the granular knowledge of the building, providing the needed flexibility into the grid. So AI is instrumental into optimizing existing assets for the benefits for an equitable and just energy transition.
Yeah, thanks a lot, Nicholas. Maybe if I can just connect or build on this. So what we often say here at Siemens Energy is, so the climate, the energy transition, it's not a question of technology in a sense that the product and the solutions, many of those are already available. We have a huge amount of data that we can use to optimize the existing ecosystem, to better understand the operation, to better understand or to optimize really demand supply side, as you explained, for the grids. And also, for example, in the generation side, to optimize really the understanding, for example, in terms of predictive maintenance of all the assets that are operating, building digital twins, and really be able to operate the assets to their full capacity before needing to replace parts, and then feed that information back to the supply chain and really along the value chain to have in time the right components available. So for us also, it's kind of instrument, it's a tool, AI, that can really help us make the best of what's available. And in addition, of course, also optimize energy systems, maybe upcoming projects in this area.
Yeah, I want to connect to that because the different parts of the energy system are really at different stages. I mean, we have solar and we have HVAC systems. These are already out there. They're in large numbers, and optimizing their operations is of course a big thing. I think also we can use AI, and this is what we're working on, to really help the new markets to move forward faster. And in that sense, it can be different things than just using operational data and such, because instead we're looking at people who are planning and how we can make these people more efficient. I mean, when we have new technologies to implement, we typically hire expert energy consultants to understand the different elements and piece it together to build the system or the production or whatever we're doing. And I think there we will also move more and more into automating some of that information that you need. So both in collecting the data you need to assess the project economics, and as well give smart recommendations and optimize at the kind of planning scale. So this is also connecting to what George says about the Siemens ambitions.
Yeah, and I feel like everybody made such good points. So maybe to summarize a bit, one thing that was implicit, I think, in the comments that the others made is that when we talk about the energy transition, often that's conflated with the power system transition. But energy systems is a broader term than this. So it's our power systems, it's our natural gas systems, it's our buildings and so forth. And so the coordination between this large complex set of systems becomes a really core part of this problem. And so to basically summarize some of the themes here, which some of the other panelists touched on as well, basically I would say AI can help through monitoring things like methane leaks in natural gas systems, or collecting data about things like the locations of solar panels. So monitoring and collecting information through forecasting of things like prices and markets or electricity supply and demand, of dynamic optimization and control of things like buildings or electric power grids in order to balance between supply and demand. And also by accelerating scientific discovery, things like learning from the outcomes of past experiments where you try to design a battery and then using that to actually accelerate the discovery of the next battery. So it's that kind of, to summarize, I guess, monitoring and data collection, forecasting, optimization and control, and accelerating science, I think are kind of some of the broad themes where AI and machine learning can come in.
Right, and maybe to add one thing. So we also see more and more use, let's say, in portions, let's say, of use cases. For example, utilizing computer vision technologies to better understand, for example, the wear of components in the field, or feedback then this information also along the value chain, just as one example, or help, let's say, field service technicians to know, to better understand what's available. So yes, it's, let's say, the overall operation, demand, supply forecasting, better dispatching the power assets, understanding the grid, and in addition, also, let's say, pieces of this whole endeavor that we are working on.
Yeah, I want to touch a bit on this dynamic nature of the grid. So I think it's really important to stress that, I mean, from an energy efficiency perspective, as well as demand response perspective, historically, those were tools used into like very specific moments. But as the grid evolved and transitioned into more decentralized and more intermittency, these events, the need to have like a demand dynamically managed is really, really important. And managing an electrical grid or an energy system together, there's a massive amount of data that needs to optimize at every time. So we need to use these AI tools in order to maximize the benefits and the value of each and every asset that we have on the grid or on the system. I mean, the energy transition in and of itself will be a very costly adventure. So we need to make the most out of the existing assets. And AI is a key tool into achieving that optimization of existing assets.
One point I'll also bring in is I think, my research skews towards thinking about like the US and European context. And I think maybe all of us are actually from these contexts. But of course, the energy transition is a global project, and sort of the situation and the needs are different in different places. And so in some places, right, the energy transition means things like making sure that the population actually has 100% access to reliable electricity. And there are actually ways that AI has contributed to this as well by doing things like trying to estimate what the current demand might be in particular places and extrapolate that to what the latent demand or the kind of future projected demand might be. And then as a result, use that as an input to processes to actually plan new grids. And then a lot of these themes that already came up, optimization of microgrids and things like this are also applicable. So, but yeah, definitely I think important to think about not just those situations where we have a lot of data, but maybe also these situations where we don't have a lot of data, but we have some proxies or we have some raw data from which we can derive proxies in order to actually kind of start the process of being able to build on this proxy data.
I want to also, like, when you talk about the global scale, it's also important to understand how much the energy system is going to change in many ways. I mean, we're going from this paradigm where we have the fossil fuels and the electricity systems, and of course you sometimes turn or a lot of times you turn coal into electricity, but you never go the other way around. But now when we have an electricity or an energy system based on electricity, batteries, hydrogen, and these can interplay, the system becomes a lot more complex. And at the same time, we're redrawing the map, because the energy map. So the place, because of this, that the source will be solar and wind, these locations where we have abundant solar and wind will become the energy hubs of the future. And that really changes, society in so many ways. And to plan ahead for that is really, really quite complex. So it's something to bear in mind here, that this the energy transition is a huge challenge and a rerouting of our global economy.
Also, when it comes to sector coupling, right? Charging of electric vehicles, for example, all connected to the grid. So everything is getting, or liquid fuels, everything is getting more and more connected. So I'm hearing this from the conversation, this topic of complexity. How can you manage that? I think also from Niklas before, I heard the topic dynamics. So for me, that sounds like, timescales of decision making are getting shorter and shorter, and you have to have ways to somehow manage that and be able to, in real time or shorter and shorter timescales, make decisions. And I think, Priya, from you, I heard this topic of sparse data, or let's say heterogeneous data. Sometimes we have a lot of data, maybe from IoT. Sometimes maybe we have only a small amount of data. And how can you combine all these different data sources together and make the best sense out of that?
Yeah, maybe I have a question for the others. I guess I feel like we've given, I think a pretty reasonable laundry list, I guess, of the ways in which AI can be used in this area. And I'm curious to hear everyone's thoughts on in what places do you think AI is essential? Is AI nice to have versus is AI not needed in these kinds of in the energy transition?
To me, I think the AI is needed when there's a massive amount of data, obviously, that is needed to be analyzed in a very short period. That's one thing. But also to use these the power of AI to predict the future. For example, most of the energy efficiency benefits that is driven with the BrainBox AI technology is based on predicting the future, and basically knowing what will be the condition in an hour, 2 hours from now, and to reduce the energy consumed, because you know that you're going to meet the constraint that is imposed into the system. So it's impossible for a human to analyze all this information and to predict the future. Just for one building, imagine managing the entire grid. Even today, the amount of data that is required to optimize an electrical grid as well as gas transmission and transportation is astronomous. And for sure, the solution that is today perceived as being optimal is probably suboptimal, because a lot of the information that is embedded into the data is not considered. So it's really critical, in my opinion, to speed the adoption of AI and to make sure that this is part of the decision making.
Yeah, I can add on for the design of energy projects. It's maybe a bit of a different story. I think AI will be crucial to survive as a project designer or project developer. Way back, you would plan energy projects on pen and paper. Now you would laugh at doing that. You would use sophisticated software to do that. And I think we're going to a future where AI is going to empower these project developers to do things faster. So it's possible to go through a small number of configurations of your project and understand, with deep knowledge, you can understand a lot. But the power to really search for optimal configurations using AI, using all the data that's out there, is just going to be so much better and lead to so much better decisions when it comes to building energy systems, that it will simply win.
Yeah. And maybe to build on that and bring another aspect in is this learning aspect of AI in situations where have things that are changing. For example, during operation, maybe in the IoT area, that you have algorithms that can adapt and configure themselves, and the outcomes are always somehow based on what really happened, which is, I think, one advantage in that field, which, let's say, conventional, for example, physics-based models often don't have. And the challenge that we see is, how do we actually combine the physics-based understanding, where we have physics-based models, with machine learning approaches together. I mean, there are approaches, I think also Priya, you are working on these. So there are methods available, and have a best combination of a predictive model that can predict the future as good as possible, based on the understanding the physics, but also in a kind of learning environment. That is, I would believe, an area where AI can really make a difference.
Yeah, that's a really good point, because I mean, at BrainBox, we are advancing our technology essentially based on the law of physics to minimize to optimize the learning and to have less data required to train the model, but also to speed the time by which we can deploy the different models and have the buildings reduce their consumption and have a significant impact on the electrical grid. So I mean, we talk a lot. So I was part of the Free Electrons BrainBox. We were part of the Free Electrons startup contest, and there was a couple of companies there that were using imagery to AI with imagery to detect default for the grid, to optimize maintenance, to predict when there's going to be failure on wires and so on. So AI is used, to your point, is used for operational, but also to predictive, to ensure that the grid is actually reliable and is not impeded by outages that are not foreseen. So it's critical to have all this information to optimize system availability, not only the management of it.
Yeah. No, and I think that, I think those like mental models for like when AI is essential, which is, I think, in my, arguably in the energy system, a lot of places, right? Like it makes a lot of sense. To maybe self-answer the like other half of what I posed, which is like maybe where AI is like not maybe appropriate in the energy system, I would say that it is places where there are strong design decisions about values that we want to encode into our decision-making system. So things like when you design an energy market, you're often making pretty strong value judgments about the distributional prices that different people will face. And the like different design choices there have very different implications from a social perspective. And I definitely have heard proposals of people saying, well, let's just use AI to automate the design of markets completely in ways that make it so that the fundamental market design is objective, and that doesn't make any sense. And ultimately, if you do anything that's data driven, it's going to ultimately reflect the values that are already implicitly encoded in the data that you have. And so I would say, using AI to automate away hard choices is certainly not an appropriate use. But I think all of these other situations where we have large amounts of data, where we have dynamic systems to optimize, where we need to do future prediction, as the others have mentioned, are definitely very good use cases.
Thanks, Priya. I'll suggest maybe we're moving to the second part of this conversation, which is around the challenges in the space. You mentioned a few of them, but can we specifically come back on the main roadblocks that are slowing down the progress to use AI in that domain? I don't know who wants to start. Maybe Georg?
Maybe I can start with a few thoughts. So one roadblock is really the topic of, let's say, acceptance, understanding, let's say, the use of AI in various aspects, like in operation, for example, also in design and manufacturing, that relates to literacy, education, and really having, an understanding across the whole, let's say, let's say set of people who would make decisions and also use AI. Of course, topics like transparency, trustworthiness, also understanding really how the AI, let's say, decisions came up, especially in operation, for example, of energy assets and grids. Also, removing bias and things like that is very important there. But we see a lot, we need to do more, education and really also, from a, let's say, regulatory or governmental point of view, help really that there's more and more people really understanding what AI can do, what it cannot do, and how to interpret the results.
Yeah, I think from a practical point of view, literacy, AI literacy is critical. I mean, we're the sector we're playing in, commercial real estate as well as energy markets. These are very, very conservative sector, and they are highly reluctant into adopting, for various reasons, the disruptive technology. And AI is probably like one of the toughest to sell into those into those areas. So increasing literacy is critical, and it's probably, aside from any technical aspect, is probably the most challenge, the largest roadblock with the AI industry as a whole is facing.
Yeah, I would agree with that. Speaking though about the technical challenges, I see the openness of data is always a challenge, especially when you're a startup and innovating in the AI space and in new energy fields. You see that the hardware, like even to, I mean, one part of it is just getting the data that you need in order to train models and do all that. And then if you want to test something in production, I mean, typically you don't build your own wind park or solar park just to do that. So I would, of course, be delighted to see even more openness to share data more openly so that we can learn together faster. But of course, there's competition that comes in that explains why that is sometimes not the case.
Could we maybe learn from other sectors where maybe this data sharing and interoperability already maybe is a step further?
Yeah, and I think, and I'm totally blanking on the name of the organization now in the UK, but there's one organization that basically the founder of that organization spearheaded the open banking data regulations and initiatives, and really kind of developed protocols and worked with policymakers to basically get open banking data sorted out in the context of the UK. And is now working on kind of bringing those models into the energy system to see if similar things kind of work in that area. So I'm very optimistically following that initiative, though, of course, apparently not optimistically enough to remember the name right now. So my apologies for that. I would say in addition to maybe the roadblocks that others have brought up, one of them I would say is that there is still some like methodological development to be done on the AI and machine learning side. So on the one hand, I think a lot of people say we have all of the technologies we need to address climate change. And I think in some ways this is very true, right? We have solar, we have wind, we have all of these energy technologies that work. But I think in some sense, the intelligence related technologies to actually help coordinate these things, especially in safety critical systems where you really cannot break the system, I think still need a lot of development. So there is some kind of just methodological development in developing AI and machine learning methods that are indeed learning from data, but can respect the physics of your underlying system. And I think some of the biggest roadblocks to that come from the fact that there aren't realistic simulation environments and agreed upon metrics with which to evaluate whether a method has actually succeeded, and to make sure that these methods actually are paying attention to or making the correct assumptions about how an energy system works. So things like the term digital twin does get thrown around a lot, which is meant to be a kind of complete representation of your underlying physical system, like your power grid or like your building, that really both represents the physics and also has real-time data flow such that it really is a proxy for the real underlying system. I don't necessarily think we always need a full digital twin. And in fact, waiting for a full digital twin is waiting much too long. But what we do need is simulation environments that provide a reasonably good proxy for what a power grid or what your building generally looks like, as well as agreed upon metrics such that if a method succeeds on those metrics, then that sort of means that we know that there is a way to kind of bring it to that next step in terms of deployment in the system. And especially for the centralized operation of power grids right now, these things don't exist. There's no kind of agreed upon notion of success. There's no way to test whether you have gotten to any notion of success. And even if you succeed, there isn't any pathway to actually deploying these things into your system to centrally operate the grid.
Interesting point. I just want to add the obvious other thing that I think would help the energy system as a whole. Of course, you, Priya, being at COP, this is obvious, but we need more agreements globally on carbon emissions and taxation or like fees on that. So that will, of course, bring a big boost of clarity to this whole world of energy.
Yeah, and sorry, just to quickly jump in too, I think definitely that makes a lot of sense. But also then the argument others make is, oh, well, we're very disillusioned about whether progress will happen given that global leaders are not coming to agreement. So it's also worth noting that individual companies can make choices like setting internal prices on carbon and making that apply to all of their scope 1, scope 2, scope 3. And that won't completely solve the issue, but I think there's a lot that can be done to sort of have companies act now without having to wait for global agreements to come through.
Yeah, I think go ahead, sorry.
No, nobody should wait. There's no reason to wait. We need to do full speed for sure. It's just it would be an added bonus. Go ahead, Nicholas.
Yeah, sorry. I think one key challenge also is data availability, and I think we've kind of alluded to that. There's a perception that all the data is private. We need to, that's kind of a knee-jerk reaction to block the adoption of, or the speed of adoption of AI. We see some discussions around making data available on an anonymized basis in order to incent the development of novel solution or optimize existing infrastructure. So going back to the literacy and having a common understanding as to what is the use of AI and what is not. I mean, the use of data is, I think there's way too much scrutiny in certain areas of the usage of data, and we need to democratize that, and we need to stop kind of demonizing the AI and the value or the privacy that there is in the data. For sure, there is private data that cannot and should not be made widely available, but there are some data. I mean, all the data are not made equal. And there's a lot of value into data that is hidden because of this knee-jerk reaction of everything is private. So that's a key impediment into the advancement of AI, in my opinion.
I mean, at the end, the energy system is global, right? Nobody can do it alone. We are all basically in this together. And maybe a question in the round, is there something, we talked about regulations and also maybe setting standards. Would you think there is also a way to somehow incentivize, to regulate, maybe a bit like in the automotive sector where data sharing and interoperability is of course something that you need to have. Otherwise, how do you enable autonomous driving, for example? Would you think that is something that should come somehow from the regulatory bodies, or more from within, let's say, the different industries, to somebody starts and then we work more together and then it comes naturally?
I would say taking the example of the electric vehicles and the autonomous driving is interesting, because there we see the technology is available, but the regulations are far behind, and I think for many AIs that will be in operations in energy systems, I mean, it will take some time before we let go of the steering wheel and allow them to fully automatically run the systems, if they are very critical. So I think it will be similar. I think technology will move a lot faster in many applications than regulations will.
Can we afford that still with the climate change? I mean, with the driving, it's one thing. I'm thinking about speed and how to accelerate this, what we need to do.
Great question. I think we need test beds where we can, I mean, that's also something to develop, but like having test beds where we can test systems to prove their reliability and then roll them out quickly, because yes, we don't have time to sit and wait around. Our energy system is in need of updates.
Yeah. I just wanted to touch back on a point that Nicholas made a couple of times, I think, about AI literacy. And I think within that, it's not just literacy about where AI can be used, but also I think what it means to actually develop an AI-powered workflow. So what is a data engineer versus a data scientist? How do you actually set up a database? How do you validate via test beds and all of these kinds of things? And I think it's basically right now you have these data scientists and machine learning practitioners who are trained to implement methods, and you have high-level leadership that can understand maybe where we're getting there, sort of the potential of AI. But I think this in between, how do you operationalize AI, is often a missing piece of literacy.
I think we're gonna move on with part 3, because I guess you cover pretty all the main blocker here. And part 3 is about the energy problem of AI itself. So if we want to be fully consistent in this conversation, we also need, as an industry, to wonder what is our carbon footprint. And I want to share here a few figures that are pretty alarming. The total carbon footprint of ICT, so information, communication, and technology, is going from 7% to 20% of global energy demand by 2030. So depending if you have an optimistic or less optimistic point of view. So I think here there's also a lot of good practice when it comes to choosing data centers, GPU, training models, how you offset, LCA approach of AI solutions. That was also very interesting to understand how you are addressing this issue within your companies, within your startups, and maybe starting with you, Priya, on the research side of things. I know you did publish a lot of super interesting papers on that. So Zara, know your thought on that.
Yeah. So I think, one thing that's actually a challenge in this space is that I would argue that the numbers are very hotly contested. So Caroline, you cited the sort of 7% growing to 30%. The International Energy Agency would say it's something more like 2% today. And so I think that, like, just monitoring and measurement, not just at a macro scale, but really pinpointing what aspects of ICT are causing what, I think becomes a really important aspect to both forecasting what the emissions might look like in the future, but also addressing them today. And I think in terms of addressing emissions, I mean, there are a couple of aspects to think about. One is like operational emissions. So due to the electricity that is used during the actual computations, let's say, that an AI or machine learning algorithm uses, what are the emissions associated with that? but then also what are the emissions associated with the embodied emissions associated with the hardware that the algorithms are running on. So from the emissions associated with extracting materials, with manufacturing the hardware and so forth. And I think one kind of interesting thing we've seen is, I mentioned this, like IEA number 1 to 2%, the number you cited, Caroline, 7%. The emissions associated with ICT have and with data centers actually specifically have stayed roughly constant over the last decade. And this is because even though we're using a lot more computation, the efficiency of hardware has also increased in pace with that. And we can't take that for granted that that'll continue. But one interesting thing that's causing is that right now, data centers, they actually replace their hardware fairly frequently, because the idea is that if you make your hardware more efficient, then you're mitigating the computational emissions. But as you continue to do that, then you actually, the embodied emissions of hardware start to take up a bigger proportion of this. So you actually have to think about this carefully. What is the actual correct replacement rate for your hardware in a way that's cognizant of the actual emissions of creating that hardware, and also then the efficiency benefits you potentially get from doing that. So that's not a very concrete, what am I doing in the research? But I think this is actually a pretty important question, thinking about the hardware and software trade-offs both.
Yeah, I mean, from our perspective, from a practical perspective, I mean, we're always aiming to reduce the number of data we're using to train our AI, as well as to that is necessary to drive the energy efficiencies we're delivering. I mean, we need to. Our goal is to save the planet and reduce the emissions. So with AI, so it's kind of a contrario to not be cognizant of that. And we're also cognizant of training our AI models when the grid is the less carbon intense, making sure that we do contribute and we're not creating more impact on the grid, on the planet than otherwise. So this is a constant question on our side. How can we do more with less? And we're always conscious of the impact we're having of using AI.
I'm curious how you practically do that. So you train your algorithms during night. You just put them on schedule, or?
Indeed.
Okay, yeah, smart.
And locations I mean, the cloud are located there in areas where the grid is less intense and so on.
Yeah, I mean that comes back to it's the same for many industries. Data centers is just one of them, that location will be very important because the amount of renewable energy will be very different across the globe. So that's one aspect, and we at Southern Lights are also supporting a company working with replacing the diesel generators of data centers. They are used for backup power, and of course that's the really polluting way to power your data center when the normal grid goes down. So replacing that with hydrogen-based systems, so and batteries can also replace those things. So there's many new applications coming that will probably reduce the energy consumption, or not maybe the energy consumption, but more the carbon footprint of the energy consumption of these data centers.
Great points that you all made. I would like to maybe add one other aspect that just comes to my mind. In addition to more efficient, let's say, use of hardware, maybe more efficient, scheduling of computations. Is there something from the method, from the algorithm side? I'm thinking of reusability. Now it seems to me like often we train, from scratch the model again, for this topic, for the next topic, then for the same again, and then for forecasting of demands and so forth. And if we had somehow more a kind of incremental approaches to use whatever is already available, of course it's a big challenge, but have methods available, and I see Priya is already nodding, that can do that. I could imagine we could be much more sustainable in the development really of our AI models.
Yeah, so this whole area of energy AI is like a huge and active area of research. And the directions it often goes in are along the lines of, one, can you actually just create more sparse machine learning models that have fewer parameters to update, but that still tend to perform well enough? And that just ends up using less energy from a computational perspective. Another one is, can you train a machine learning model? So especially for very large machine learning models, it's sort of the development and training of the model rather than the actual use of a trained model that dominates the emissions. So then some have thought, can we somehow come up with a base model that has some common representation that quote unquote generalizes well, that kind of works well or can be just tuned a little bit to work well across a wide variety of areas? So you train this big base model once, and then you maybe tweak it and fine tune it, but that part ends up being cheap and you can do it across a lot of different applications. And then the third one that comes up is actually a pretty classical aspect, which is called online learning. And the idea is that you start with a model, and when you get a new data point, you just know how to update the model incrementally to take that data point into account rather than retraining on your whole data set from scratch. And online learning is not actually, it is an active area of research, but it's actually like just a methodology and a workflow that has existed forever. And I think it's actually a pretty simple step that a lot of entities could take rather than retraining your forecasting model from scratch every 24 hours. Just update with the additional data point and maybe retrain from scratch later down the line if you feel like you need to do that, but it doesn't have to be so frequent.
And even maybe reuse the forecasting model from, let's say, one area of the world or from one application. Of course, it can be retrained over time, but maybe even take that as a basis for another one so that then we don't always have to start from scratch again.
Yeah, that's the kind of strategies that we're applying, or at least we're aiming to apply.
The other one, which also comes up a lot, is, I mean, I think startups do this fairly well, but not all companies do, which is the extra resource use justified based on the utility that the model is giving you with an extra 0.0001% accuracy? And I think being very concrete about those trade-offs is important. If you have a good forecasting model of electricity demand versus if you have a very good forecasting model, even if your accuracy is some percentage better, how much better is the actual decision that you're making downstream? And if it turns out the answer to that is not much, then maybe it's not worth going through the extra development cycles or creating the fancier model on the front end.
Agreed.
Thanks so much for all this insightful advice. We are now running a bit out of time. Does someone wants to add anything? Last advice, last comment? No, we all good. Everyone wants to have dinner now.
Maybe a last thing I'll say is that when it comes to energy systems, of course, AI is not the only technique that is used or like has historically been used. There are traditional methods from optimization and control and many kind of ways of doing things. And so I think the most promising methods I've seen are ones that really combine those different paradigms, really learn from what has been done previously, and additionally bring data where that data can bring strengths. And so I think just taking a very like multi-perspective approach and merging different perspectives and techniques is just, I think, the most fundamentally important thing to do when moving forward in this space.
You want to add something, Jörg? You could hear.
I think what I heard also from the discussion, we are all in this somehow together. It's climate change is a global topic, and this data sharing and working together, collaborating, reusing, and maybe even resharing not only data, maybe also models, maybe another thought to pitch here. I think this is something that's important to be successful overall.
Yeah, it's about collaboration at the end of the day, I think. Anton, maybe you want to say last words, last comments?
Yeah, I think tying back to this, the many topics here, like energy efficiency is going to be extremely important. It's the cost of doing many things that we used to do for cheap with in the fossil paradigm are no longer going to be as cheap. So being energy efficient, both when we're using AI in our data centers, but also using AI to become energy efficient, is going to be crucial going forward.
Yeah, I
And
think
last
we,
word,
yeah,
Nicholas.
from a like a societal perspective, I think we ought to use this new tool, this powerful AI tool for a just and equitable energy transition. I think it should be on top of mind of everybody to optimize what's on the table and make sure that we don't create assets or create a larger toll on the planet unless it's really necessary. And AI is a real enabler for that optimization.
Thanks so much, Nicholas. So I want to thank all the attendees who joined us today, and want to thank also all of you for this insightful, really interesting conversation. It was, I think, it's pretty rare as well to see people from different, industry research, startups, spending time like that to exchange about the different experience and sharing best practice and advice. So really, I want to thank you all. If anyone wants to reach out to our speakers today, I invite you to your email address in the chat, if not done already. And you can find the recording of today's the Good AI conversation on our YouTube channel. And for all of you who would like to join a community and join a team of experts as Priya, as Anton, Nicholas, and Georg, you can do by joining by applying on thegoodai.co. So thanks again, everyone. Thanks all your speakers, and I wish you a very nice
much.
Thank you.
Take
Bye.
care. Bye.
Great talking.
Great. Bye.